Thanks, everyone, for coming. My name is Xiao. I'm a director of software engineering at Salesforce. With me is my colleague, Thomas Hargrove, which is a senior director at Salesforce. So today, let's go take a peek inside the enterprise cloud at Salesforce. We're going to be talking about how we manage Kubernetes at work at scale. So we also listed our email address there. So if you have any questions, any discussions you want to talk about after the talk, please feel free to email us. So here is today's agenda. First, let's talk about the unique challenges in using Kubernetes at Salesforce. Salesforce is a leading cloud company. We own many private data centers. As we develop a lot of the internal management system to manage our private data centers, Kubernetes is a open source software which doesn't necessarily fit into those existing management tools. That gives us a lot of the unique challenges. Our team started to work on Kubernetes back in 2015. We actually started to use Kubernetes when it was Kubernetes version 1.3. Kubernetes has gone a long way from there. We also have gone a long way from there. Today in this platform, I want to share what we have learned in this journey, what worked, what didn't work, and what can be improved. So today, we're going to be talking about 4 aspects of solutions. So first one is multi-tenancy and security. How do we manage Kubernetes cluster when multiple tenants using the same cluster with necessary protection? Second one I want to talk about is deployment management system. We actually developed in-house the internal development management system. And the third one is orchestrated production visibility. We actually have open sourced some of this software. I'm super excited about it. Tom here is going to talk about it in a later section of the presentation. And last but not least, I want to talk about how do we do testing, monitoring, and alerting. And then we're going to be talking about what's the future projects. We have something in mind, what's going to be next for enterprise cloud. So first, let's take a look at the unique challenges for the enterprise cloud for Kubernetes at Salesforce. So who here, I have a question for you guys. So who here is deploying Kubernetes in private data centers? Awesome. And who is actually deploying Kubernetes on bare metal machines? Awesome. I'm glad some people here know exactly what we're going through with these challenges. And the next challenge I want to talk about is network isolation, which means from production data center to production data center, they don't talk to each other. And also, we have the challenge of restrictive privileges for the end user, which means not everybody can just log into production data centers. So let me give an example for this particular challenge. Let's say we rolled out a change to multiple production data centers, and it has an issue. So what do? Developers can't just log into production data center anytime. And even then, we get some people who has the privilege to log into production data center to look at these resources. They can't really just log into multiple production data center at the same time. So this actually makes our Kubernetes management system extremely challenging. And also from a security perspective, we need to uphold the standard to the enterprise level container security. Okay, so next challenge I want to talk about is very interesting, internal integration. What that means. Salesforce as an enterprise, we have a lot of the internal services and teams that we need to integrate with, which means we cannot just use any software off the shelf. We have to use the Salesforce ones, which means we have to develop our own interface on top of the Kubernetes clusters in order to use the Salesforce services. So next challenge. Yeah, we have a lot of challenges. Next challenge I want to talk about is we have a lot of the internal teams to support. We're not just aiming for one team. We're aiming for develop the Kubernetes platform which fits all teams in Salesforce. And those teams, necessarily, they have to be the Kubernetes experts. We develop tools for them. So for example, we have hundreds of teams right now which are deployed on our Kubernetes cluster in each of the production data center. And also, each team has multiple applications running in those production data centers. So the last challenge I want to talk about is the requirement for the advanced tools. When we first started to use Kubernetes in 2015, there were not a lot of advanced tools. I'm sure a lot of you guys know that. Which means we have to develop our internal tools in order to satisfy the needs of, like, for example, the multiple production data centers and the scales we're running at. Okay, so we talk about all those challenges we are facing. What did we do? So first one I want to talk about the solution is multi-tenancy and security. So each of the tenants in the Kubernetes cluster will get its own namespace, which gets a native Kubernetes separation by default. But on top of that, we actually put additional security to satisfy the enterprise security needs. For example, we have MTLS communication with internal PKI services. The certificates are actually automated, rotated. Also, we use OPA, the Open Policy Agent, and RBAC to limit access to each of the namespace to protect our tenants. Instead of using the native Kubernetes secrets, we actually use internal secret management system. And on top of that, on the shared cluster, we have automatic detection of malicious behavior so that our tenants will get alerted and necessary action will get taken. Across the board, we also have container security for forensic analysis and security concerns. We actually scan the container images before they even go to the production. And also, across all Git repos, we have co-signing to make sure that all the check-ins are properly signed. I guess from the previous slide, I cannot mention that we actually deploy bare metal machines. So because we're doing that in-house, we actually develop the tools for automatic patching for those hosts with health checks. Also, we have the change tracking and sequencing on the host level as well. To better support multi-tenancy and provide a consistent setup across all teams that's using the same Kubernetes cluster, we integrated with Service Mesh, which means if you deploy on our Kubernetes cluster, you'll get some built-in features for free. For example, API throttling, load balancing, and many other features. The second aspect I want to talk about is this internal deployment managed system that we deploy in-house. So like I mentioned, we started to use Kubernetes when it was 2015. So we developed this as a version 1 deployment system, which proved that it actually worked pretty well. So let's look at this graph. We define our own manifest formats, and then we're checking those as a JSON-net in the Git repo. If you're not familiar with JSON-net, it's actually a pretty clever JSON templating tool where your template is a superset of the JSON syntax. If you're interested, just go check it out. It's pretty cool. Then, through the CI system, it is actually getting delivered through different deployment pipelines into the production data center. After it gets into a production data center, we develop in-house a controller that will get those JSON files and create CRDs on the Kubernetes cluster. And after that, an operator actually is also running each of the Kubernetes cluster, will watch for every change of the CRD. So we have creation, updates, and deletion. So whenever those CRD changes, the operator will actually do the corresponding action to that Kubernetes cluster. So the cool thing about this operator is we actually inject Salesforce integration features and security info within the operator. So this system is a goal-seeking system, so that any change that gets checking in the Git repo will be quickly reflected in one or multiple productions. And also, I think that's pretty cool because sometimes people log into the Kubernetes cluster in production and modify something, and this operator will actually override this change to back the previous state corresponding to the JSON net in the Git repo, because we do resync of the operator pretty fast. So we say that this system works because we already have 40,000, almost 40,000 PR checkings in this system, which means more than 40,000 Kubernetes deployment has happened in this system. So we allow this system to have so many deployments because the teams actually manage the deployment approval by the PR approval, so it's pretty scalable. So we call this version 1 because after we've done this, we found some challenges. For example, there's no blue-green deployments. And also the manifest formats we define in-house is kind of complex to learn. Also, this process is pretty much all proprietary. That's why, to address all those challenges, we're marching towards version 2, which is a much more open source solution. So from left to right, we're checking the Helm charts, and the CI system picks up the checking, and then the delivery pipeline will ship it to replicate storage. And one Spinnaker instance will be triggered on any change of the Helm charts in the storage, and do the deployments in the multiple production data centers. And in order for a new data center to get set up very fast, we actually utilize the Spinnaker templates in Git so that the new pipeline will be materialized without human intervention. Sorry. Cool. So next aspect I want to talk about is orchestrated production visibility. So if you guys remember, I mentioned that there's network isolation, production data center doesn't talk to each other. There's also privilege, restrictive privilege, so that people cannot just using their laptop to log into production data center as they wish. So those restrictions have been making ad hoc analysis or just I just want to look at the production deployment. Those things are hard. To address those, we actually develop in-house this orchestrated production visibility pipeline, which is pretty cool. If you look at this graph, in each of the production data centers, we deploy a component called snapshot producer, which watches the Kubernetes Kube API server in the Kubernetes cluster and gets all the status of all the Kubernetes resources in that cluster. And it actually ships all the state of the current Kubernetes resources from production through Kafka into the R&D data center, where we set up a SQL instance. So actually, in that SQL instance, you have a read-only copy of all the state of all the Kubernetes cluster of all the production data centers. In front of that, we have the pseudo Kube API. We call it pseudo Kube API because it's not a real Kube API server. But the cool thing is it speaks the same protocol as the Kube API server. This actually enables people can use standard Kubernetes tool like kubectl and kubedashboard against this Kube API server. actually querying the read-only copy SQL in R&D data center instead of actually logging into the production data centers. So this model has worked really well. We have customers using this tool all the time, and when they're using it, they don't know they're querying against the read-only copy in the R&D data center. They thought they were querying against the production data center. So after we built this initial system, we had in mind for visibility. But after it was working, it's like almost we found it so helpful for a lot of the other user cases. With that said, I'll hand over to Tom to talk about those user cases.
Thank you, Xiao. So when we built this system, we quickly found that just querying the raw SQL was incredibly powerful for a lot of scenarios. So let me give a quick example. Let's say an alert goes off, and I investigate, and I find that the root cause is a container that has a pod with an init container that's in a crash loop, and it's just failing to come up. So I found that it's happening in this one cluster, and now I want to know, is this happening in all the other clusters? Well, I could run a whole bunch of kubectl commands against each cluster, and I could collate all the results, and if I want to share it with my coworkers, I could send it to them in text. What we found works much better is just writing a little bit of SQL. This is valid MySQL syntax. This query finds all pods and all namespaces in all clusters with a phase of pending and some message on the init container. And the only part that might look a little funny is where it says payload dash greater than, and that is MySQL's shorthand for JSON extract. The payload column is the Kubernetes resource in JSON format, the exact same thing you would get from kubectl get pod -o JSON. And on the right side is the JSON path I want to pull a value out of. So let's run this query. And this tells me I've got 4 pods with this issue, 2 in cluster 7 and 2 in cluster 21. And I can see that the ones in cluster 7 have been broken for quite a while because one of them's restarted almost 10,000 times. And I can see that it's consistently the cert init container that's failing. So this is a useful query. I might want to run this in the future after we've rolled out a fix. So we have a component called SQL Reporter where I can check this query into a config map. It lights this up on a dashboard, and now this query has a URL. So I can hit that URL at any point and get the results of this query. I can share it with my coworkers. So I go roll out a fix. I go to the dashboard, and no results returned, so I've fixed it. But now I want to know if this issue comes back. So we have another component called the SQL Watchdog. Again, a config map. I could drop in the same query, and I could set it to page the on-call person if there's ever a new row returned. We also have a third component that's very similar where I can compute a custom metric. So if I don't have a built-in metric I need, but I can compute it using SQL, I can drop it in there. We use that for things like how many nodes are on this version of Docker, or this version of Kubernetes, or what is the count of pods by phase? And that's been really helpful. And this has actually been used so heavily that we hit the size limit on a config map from handwritten SQL queries and had to do a little work to condense them down. On the same note of visibility and monitoring, this is an open source project we released last month that I'm very excited about. Sloop is a Kubernetes history, a tool for capturing Kubernetes history and showing it to you visually. So you deploy this into the cluster. It monitors, keeps track of about 2 weeks of history, and lets you explore that history visually. So what I'm showing here is the last hour of the Lizard deployment. So this timeline at the top, green bar is the deployment. These orange bars are pods. You can see I started with 4, and a deployment happened right about 11:20. I started to bring on new pods, and as those became healthy, I drained the old pods. And at the bottom are replica sets. And if you use Kubernetes, you know that Kubernetes can be a little lazy about garbage collecting old replica sets. They usually just count 0. There's actually a new replica set that started 11:20 but got clipped off the bottom. But in addition to showing this visually, you can actually drill in and get Kubernetes events and payload changes. Like you could see what actually changed in this deployment at this time. And one cool use case we have internally, there's a team that for each test run spins up a Kubernetes cluster, runs all their tests. It includes Sloop in the cluster. And before they delete the cluster, they download a copy of the Sloop history. So if they want to debug a failure after the fact, they can load it into the Sloop UI, figure out what the issue was, and that's them debugging a cluster that doesn't even exist anymore, which I'm not aware of any other tools that does this. Unfortunately, we don't have time for live demo, but the website address is there, and we're giving demos at our Salesforce booth tomorrow from 1 to 3, and Thursday from 3 to 5. This next slide talks about our approach to quality, or our team's approach to quality. The first one is unit tests, which is very common. But the next part is we tend to intentionally underinvest in traditional integration tests and ED tests. These are typically things that you would run in a VM, and you'd bring up 3 different components, and they would talk to each other. The problem is, a lot of times these testing environments don't perfectly match production, and so you miss some things, but also sometimes you get false alerts. Maybe there's not as much memory in the test environment as production. So what we invest in instead are watchdogs. Watchdog for us is a deployment or daemon set that runs a set of synthetic checks. And a synthetic check is like pretending to be the user. So I'll change a deployment. I'll make sure that I can connect to the new pods. I'll route some traffic through make sure I'm using the right DNS. I'll read and write some data to a local volume. Maybe we have one that hits the API server with intentionally invalid requests to make sure that RBAC rules are catching it. So these checks we run a couple times a minute. We run them in every cluster we operate. And when they detect a failure, we can wire them up to page the on-call person. We write the results to CRDs, which we can, again, query in SQL and view the history of in Sloop. But this saves us a lot of time because we write one check and it helps us prevent regressions on new code we write. It helps us monitor all of our live production clusters, so we know that every feature is working at all times. And it really just helps where if there's any sort of inconsistencies across production data centers, say this new one has a different chipset and a slightly different disk driver, well, maybe I can't get test beds that perfectly match every production data center, but at least I know that I've got these checks. And if there is an issue, I'll know it immediately as opposed to getting surprised later on. Next up is how we roll out our changes using phased release. This is common practice. We first roll to a test bed, and then an R&D environment with customer clusters, and then a subset of production, and then the rest of production. We have a few hours of bake time in each phase, and all we're doing is seeing if any watchdogs fire and page us. And if not, we are confident that these new bits are good and we can proceed forward. But what we also do is for the vast majority of new features, we build them disabled by default. So I'm going to go build a new feature. I will first put in a Boolean into the config file, set it default to false, and then my code is largely under an if statement. What this means is the next phase release goes out. My code is now in production, but it's not doing anything because it's disabled. Me, as the subject matter expert, can go in after the phase release and go turn it on, monitor my feature that I know well because I wrote it. If everything's good, I'm done. If not, I can quickly switch it off. And what's really great about this is I didn't have to roll back all 4 phases because I discovered a bug. I just turned off the feature. And so that greatly minimizes, well, and then the other thing is, if it was an enabled by default, it would go out in the phase release, and the person that's running the phase release might not be the expert in that. So then our outage might last longer. Last is repair automation. Because we have this watchdog signal flowing through CRDs, flowing to SQL, we just have a simple automation system that can detect unhealthy hosts and trigger power cycle based on that signal. This last slide talks about some future projects. So the first one is mutating admission controllers. We're starting to use these much more heavily internally for injecting things around certs or logging or a whole bunch of different things. We found this to be an incredibly powerful integration point in Kubernetes, but also probably the most dangerous one. If you're not familiar with these, you can basically say, hey, Kubernetes, when you go create this resource, before you finish creating it, send it to me. I'm going to make a little bit of modification. Send it back. There's a lot of boilerplate code, and it can be tricky to validate these right. So we're building a common framework that makes that easier, so we can ship high-quality ones and consistently validate these. Next up is cost to serve reporting and alerting. So with bare metal first-party machines, underutilizing hardware wasn't something we were going to page someone about because we've paid for the hardware. If we don't have workload for it right now, we can't give it back. As we move more into public cloud, this becomes much more important because we can auto-scale up and down VMs. So we're going to reporting and alerting both for overutilized and underutilized hardware. So like if something is wasting money, we want to get the tenant to fix that. But if a process is trending where they're using more and more memory or more CPU and they're going to hit some limit, we want to let them know before they hit that limit. Next up is one-step onboarding. So if an internal team wants to build a new microservice and they're kind of new to this space, all they need is a repo and source code and a build script and a Docker file and a CI job to publish the Docker file and a Helm chart and a Spinnaker pipeline, and then they get their app deployed to a test bed. But that's a lot of new technologies to all take in at once. So we're building a one-step onboarding portal. You can fill in a few details about your team, and it gives you a hello world app fully built and deployed, and then you can start piling in your business logic. Next up is better Helm validations at PR time. So our Helm workflow today is I go make a change to a Helm chart, I send out a PR, I have a peer review it, it gets merged, CI builds it, ships it. Spinnaker takes it and applies it to Kubernetes. But there's a bunch of internal requirements we have for our Helm charts for security reasons or for auditing or any number of things. We rely on OPA to fail that deployment if there's any issues. But this is way down the pipeline, and we would much rather just have a status check on the Helm PR saying, hey, if you check this in, it's going to fail because you forgot to put the tag for resource accounting purposes. So that's something we're working on. And the last is an open source version of the visibility pipeline we talked about earlier with the sudo API and the SQL. The current version is a little coupled to some internal systems, but for not a whole lot more work, we're going to build one that's easy to deploy to public cloud and open source for other people to use, because we've found it to be incredibly valuable. And with that, that's all of our prepared content, and we're happy to answer any questions. We have a microphone right here. Do you mind using the microphone for the recording?
Thanks for the wonderful talk.
Thanks.
So part of the thing that you're kind of doing with the read-only SQL copy could also be achieved through like a logging pipeline that does similar.
It is a logging pipeline.
Right.
We're logging messages to Kafka, but this is something where on the other end we're exposing it as if it's a Kubernetes API, so you can use your standard tools. As opposed to most logging systems, you could write a log query. But we can actually run kubectl or kubedashboard. But sorry, what's the question?
Yeah, the question is basically the kind of what made you kind of use the kubectl API as the API as opposed to like what usually used to kind of for the logging, monitoring, logging and aggregation and.
So are you talking about kubectl logs?
No, basically the logging that the cluster produces, say audit logs or the regular API server logs, it could probably give you the same information that you're.
So by the way, we do have that as well.
Yes.
Just no one uses it. So the nice thing about exposing a Kubernetes API is as new tools are developed, any user can just spin it up, point it at the API, and so like something could be invented tomorrow, or like Sloop came online, we can point it at the sudo API, and now we have a historic analysis tool, whereas we don't get that for free if we just ship it to a log storage and search system.
And also I can add to on that is So for this visibility pipeline, we're more like looking at the current status of actual Kubernetes resource status. And for loggings and stuff, we actually have a building house logging system as well to ship the logging from the production to a visit, like a dashboard and stuff. So it's actually their internal, that falls into a category that there's actually internal tools that we need to integrate with to build, use those tools on top of Kubernetes. So to a point, yes, we do have those.
Got it.
Yeah.
The other question is about the framework for admission controller. Did you guys like investigate if there's something similar available in open source? Or are you guys going to be open sourcing yours?
Yeah, so we did look at some open source projects. I think there was one we found, which was pretty close, but not exactly what we wanted. It was not generic enough. So when will be open source, we'll talk about more stuff, but I mean, it's much more generic than what we found, what was.
I think that's one thing I forgot to mention. Most of the things on this future project, we're going to try and open source. Like that, we've had a really good experience open sourcing Sloop, and so as much as possible, we're going to try and open source future projects. It's actually been a really great experience.
So stay tuned. We're going to have more open source projects coming.
Thanks.
Any other questions?
Just one quick question. Yeah. Like, how do you manage secrets? You said like you're not using Kubernetes secrets, so is it something like you guys have built or like you use open source?
It's a proprietary internal system we built, so.
Yes, so it will uphold to the enterprise standard. We can't just use the Kubernetes secret management because that's also good, but it's not like satisfying the enterprise need.
Cool. Thank you.
Thank you.
We did it.